Okay, grade 12, this is the November 2018 question 8 question on internal resistance. It says to you, the battery in the circuit diagram below has an EMF of 12 volts and an internal resistance of 0.5 ohm. Resistor R, this is resistor R over here, has an unknown resistance. What is the meaning of the following statement? The EMF of the battery is 12 volts. Now remember, when it says to you the EMF of the battery is 12 volts, they're wanting you to use your definition of EMF, but they're wanting to use it specifically in relationship to this 12 volts. So we know that EMF is the volts, the total volts the battery can supply, but volts are joules per coulomb. So what we say is the battery supplies 12 joules of energy per coulomb charge, and that is what it means. 12 volt battery provides you 12 joules of energy for every 1 coulomb of charge that passes through it. Now it says to you, the reading on the ammeter, here's the ammeter, is 2 amps when switch S is open. Okay, so let's have a quick look. What's happening when switch S is open? When switch S is open, we actually still have, can you see here, a complete circuit. Okay, the only thing that's happening is we are bypassing the 2 ohm resistor. So this circuit is actually a closed circuit for resistor R when the switch S is open. So it says to you, calculate the reading on the voltmeter. So the reading on this voltmeter, can you see here's the voltmeter here. The reading on the voltmeter is going to be how much voltage is going to the external circuit. So we know that this battery has an EMF, okay, of 12 volts. Then what happens is the resistance in the battery loses you some volts. So if we look at the internal resistance, we know it's 0.5 ohm, okay. So if we want to calculate how much voltage is being lost, we need to find V lost, okay, equals I little r. So we know that the current in the circuit is 2 amps, and we're using this current, it's a closed circuit for resistor R. So 2 amps times the internal resistance of the battery, which is not going to change, is going to give you V lost. So V lost equals 1 volt. So inside the battery, 1 volt of the potential difference is being used up, but the battery can supply 12 volts. So 12 volts minus 1 volts gives you 11 volts will be the reading on the voltmeter, because it is telling you what is going on in your external circuit. Now it says calculate the resistance of resistor R. So if we've got 11 volts going through resistor R, we can have a look here, 8.2.2. We're going to use V equals IR again. We know we've got 11 volts in the external circuit. We know the ammeter's got a reading of 2 amps. So this will be 2 times R. So the resistance of resistor R is 11 over 2, which is 5.5 ohms. Okay. So that's fine. We know now that this is 5.5 ohms. Now it says to you, we've closed this switch. What have we done when we closed the switch? Now the electrons coming out the battery have a choice of 2 different ways to go home. What have we done? We have created a parallel circuit. What happens when we make a parallel circuit? Every time we make a parallel circuit, the resistance will decrease, okay? So if resistance decreases and the battery can't change its EMF, because the battery can't change its EMF, so we can't supply more volts. If the resistance decreases, immediately the current increases. But if we put an extra current through the internal resistance, this means the lost volts, yeah, because remember the lost volts is I little r, okay? So the moment the current increases, I increases, I times R, the lost volts are going to increase as well. So if we supply 12 volts and inside the battery eats up all of those volts, what's going to happen to the external circuit? The voltage on the external circuit will decrease. Okay, so the answer here is decrease, and it's because the total resistance dropped because we made a parallel circuit, which led to the current increasing, okay, and therefore the lost volts increased, and the total EMF of the battery cannot change. So if more volts are lost on the internal resistance, the external potential difference has to decrease, so the reading on the voltmeter will decrease.